Hello class, in this video we are going to be talking about chemical compounds, which is a part of basic concepts of chemistry. In this video we are going to be dealing about how the substances around you are formed and what they actually contain. So if you want to watch this video, if you want to understand the stuff in this video, I highly recommend you to watch the previous videos of the Basics of Chemistry series, because those videos, the information in those videos is very important for you to be able to understand this video. This video is basically a sequel to the Basics of Chemistry series, the Basics of Chemistry playlist. And if you're on that playlist currently, I highly recommend you to watch the previous 3 videos. And if you already know about the atom, if you already know about the periodic table, well, you can watch this video. So the link to the Basics of Chemistry playlist will be in the description down below, and I highly suggest you to check that out if you don't know about the Basics of Chemistry yet. Now let's learn about the ionic bond. So what is an ionic bond? Well, an ionic bond is where one atom provides its valence electrons to another atom, okay? Then this one, the atom that donated gets positively charged because electrons are negatively charged, and and the atom gives that that electron away, so it gets positively charged because it has more protons than electrons. And the atom that receives these electrons get negatively charged because electrons are negatively charged and they receive the electrons, and thus they have more electrons than the protons. Okay, protons are basically positively charged particles if you haven't watched the first video, which I highly suggest you to watch. Okay, so now one atom is positively charged and the other atom is negatively charged. So as you already probably know, opposite charges attract, right? So the positively charged atom bonds with the negatively charged atom, just like the opposite charges attract. So in an ionic bond, one atom contributes its valence electrons to another, thus filling the other atom's valence electron shell. So in most cases, the valence electron shell can hold 8 electrons. Okay, so one electron which has let's say one atom which has, let's say, 7 electrons, it needs one more electron to fill its electron shell so it can be stable. So what it does is that it gets an electron from another atom which only has 1 in its electron shell, and that's how the ionic bond is formed. Now, the other point of the ionic bond is that the donor atom should have as many valence electrons as the receiver atom needs to fill its outer shell. So basically, if the receiver atom needs, let's say, 1 more electron to fill its outermost shell, the donor atom needs to have the 1 electron in its outermost shell. For example, sodium forms ionic bonds with chlorine because sodium only has 1 electron in its outermost shell, whereas chlorine has 7 electrons, and it needs only 1 electron to have a stable octet, to have a stable shell, or to have a stable outermost shell. So this is how the reaction works. When sodium reacts with chlorine, Na stands for sodium, for those of you who don't know. Sodium has 1 electron, as you can see in the diagram. It has that little the little dots represent the electrons. So it gives 1 electron to chlorine. Okay, so then sodium gets positively charged, as you can see, since it has more protons than electrons, and chlorine gets negatively charged. Okay, it has a charge of 1 negative since it only has 1 more electron than it had before, 1 more electrons than it has protons. Okay, now let's move on to the next part of the ionic bond. So what if the donor atom doesn't have exactly as many atoms as the receiver needs? Well, then multiple atoms are used to form bonds between the 2 elements. Okay, let's say magnesium has 2 valence electrons, while chlorine needs only 1 valence electron to fill its outermost shell. It has 7 electrons. Okay, so magnesium can give 1, but where does the other one go? Well, then another chlorine atom comes up and says, hey, I also need your electron, and they start bonding. They start making 2 bonds. So in this case, 2 chlorine atoms form bonds with magnesium. Basically, the magnesium gives two electrons to two different chlorine atoms, and it doesn't have to be chlorine atoms. It could be any atoms that need one valence electron, one electron. Okay, so magnesium gives one to chlorine, as you can see in the diagram, and the other one to another chlorine atom, which gives magnesium a charge of 2 positive. Okay, just keep that in mind, because it gives away 2 electrons and has 2 more protons than electrons now. Okay, so chlorine gets 1 electron each, and now each chlorine atom has a single negative charge. Okay, both the chlorines then have what do you call it? Both the chlorines have a negative charge, so the net charge of the chlorines is 2 negative, and the magnesium has a net charge of 2 positive. So the net charge of the overall compound is 0, because 2 positive and 2 negative cancel out each other, and that's why magnesium chloride is a stable compound. Now let's learn about another type of a bond, which is the covalent bond. In this type of bond, 2 atoms share electrons. Okay, so as I already told you, atoms share the valence electrons in order to fill their valence electron shells. So I need to explain this to you in a pretty practical manner. So let's say I have $100, okay, and for $100 I cannot get a really good birthday gift for my friend Jack. Okay, so I really need more money. Let's say I need $200. So what I do is I talk to my other friend. So I talk to William whether he wants to share his money with me so we can buy him a better birthday present. So we collect. Let's say he has about $100 too. So we together share the money, and we have $200 in total. So we use that $200 to buy him a common present, and we have a much better present to give our friend. That's how covalent bonds work. And instead of money, you have electrons, of course. So for example, oxygen only needs 2 electrons to fill its outermost shell. So it gets help from another oxygen atom. So what it does is that it shares 2 of its electrons with the other oxygen atom, and the other oxygen atom also shares 2 of its own electrons with the first oxygen atom. So basically, both oxygen atoms have 6 valence electrons, and they need 2 more to make a stable octet. So what it does is that it shares one of them shares 2 of its electrons with the other one, and the other one shares 2 of its with the first one, and that's how a covalent bond is formed. And fun fact, you don't need to know it for this video. So what happens is, how do you represent covalent bonds? So to represent covalent bonds, for every 2 electrons shared, you put a line between the atoms. Okay, and that's basically how you represent it. Well, can covalent bonds be formed between 2 different elements? Let's answer that question in this slide. Yes, of course, they totally can. All that has to be done is that both the electrons should agree on sharing the both the atoms, should agree on sharing the number of electrons that the other atom needs. Okay, so basically both the atoms need to cooperate with each other. For example, carbon and oxygen do the same thing to form carbon dioxide. So carbon has 4 valence electrons. It needs 4 more valence electrons to fulfill its outermost shell. And oxygen needs 2 more to fulfill its outermost shell. So what carbon does is that it calls an oxygen and says, "Hey, can we share 4 electrons?" Okay, then carbon shares 2 of its electrons with oxygen, and oxygen shares 2 of its electrons with carbon. So in total, oxygen's outermost shell is fulfilled. Oxygen has 8 electrons in its outermost shell, and it's now stable. But what about the carbon? Carbon only has 6 now because it got 2 more from oxygen and it had 4 already. So what carbon does now is that it gets another oxygen atom and says, "Hey, I want to help you too. Can you help me?" So, and that's basically what they do. It forms bonds with another oxygen atom. So let me tell you a few examples of the ionic bonds. We have calcium chloride, of course, where calcium has 2 valence electrons, and chlorine, both the chlorines need 1. And of course, you have potassium chloride when potassium has 1 valence electrons and chlorine needs 1, and they form a bond called potassium chloride. And of course, they get charged in an ionic bond. In a covalent bond, you don't really have charges. And let's see examples of covalent bonds. In covalent bonds, you have water, H2O, of course, the substance that is very important in your life. You have oxygen, which needs two valence electrons, and hydrogen only has one, which means that it only needs one more to fulfill its outermost shell. Hydrogen only needs two electrons, by the way, because it only has a single electron shell, and they form H2O, of course, which is water and which is a very important compound in life. Similarly, you have methane, where carbon needs four electrons and hydrogen needs one, and carbon shares its electrons with other hydrogens and makes methane. And that leads me to the end of this video. Thanks for watching, guys. Please like this video if you enjoyed it and learned something new from it. Please subscribe to my channel if you want more content. I'm desperate to show you more content. Share this video with your friends and family, and thank you.